So we have a improper integral from 5 to infinity e to the negative 1 over x squared dx. So first I did u substitution. I took negative 1 over x. Then I moved the x up from the denominator up to the numerator. So it becomes a negative 1. Then I did the power rule. I moved the negative 1 over to in front of the x, and then I minus 1, so now the power is negative 2, and then the negative 1 and negative 1 cancels out into a 1, and then I move the x to the negative 2 down, so now it is 1 over x squared. And then I divided both sides by 1 over x squared, so now it should be x squared du. And I also took the limit from as t approaches infinity, and I just replaced the infinity with t as a variable. So now it is 5 as the lower bound of integration, and t is the upper bound. And it is e to the u over x squared, and then x squared du. And then the x squares cancel out, leaving just a eu, or e to the power of u, du. And then I take the interval. In this case, I just apply the exponential rule, which is just ax over ln a, or e to the power of u over ln e. ln e is just 1, leaving just e to the power of u. And then I just plug u back in, and u was negative 1 over x. And then I plug in the bounds of integration. So now it is e to the negative 1 over t minus e to the power of negative 1 over 5. And I plug in infinity where the t was, which makes it negative 1 over infinity. And that approaches 0 because as the denominator gets bigger, the overall fraction gets smaller or closer. It approaches 0. Then I have negative or minus e to the negative 1 over 5. And now the overall equation is just e to the negative, or e to the 0 minus e to the power of negative 1 over 5. And then e to the 0 power is just 1 minus 1 over the 5th root of e. And that is the answer to this improper integral.